Okay, so the scenario is we have a cliff, yes? And on top of this cliff, we have a body that is projected vertically upwards or horizontally.
And we see it's projected with a velocity of 10,
Wow.
of 10.2 meters from the top of a cliff.
From the top of the cliff. So this is upward projection. At what velocity? This is 10. 10 root 2 g meters per second. At what angle?
They didn't give us the angle.
They didn't give us the angle, but we can maybe say that the angle is alpha. I prefer writing theta. Yes? What happens? This particle continues and clears the sea. It continues and clears the sea at a point, what? 100 meters. Are you sure?
Yeah, 100 meters from the vertical.
100 meters. Then, what is the height of the cliff?
Because 50 meters.
The height of the cliff is basically 50 meters. Then what are they asking? Read the question.
Show that there are two possible angles of projection which are perpendicular.
Taking this to be a trajectory, the equation of a trajectory, we derived it. Yes? It is y is equal to x tan maybe theta, yes, minus gx squared over 2u squared into 1 plus tan squared theta. This is always in log tables. The x is squared, and the u is squared. This is always in log what?
That's the standard formula.
It is standard formula for a trajectory. Okay?
It's a trajectory.
How do you know?
It's a trajectory.
A trajectory. Of course, any other body that you toss in space follows a trajectory path. Therefore, it is a trajectory at any point. For as long as it hits a point, yes? If it has hit maybe a point here, at this point, this path describes a trajectory.
As it was thrown in space, it made that angle in space.
Yeah.
Okay. So every trajectory.
Yeah. No, any other body that you toss upwards is actually a trajectory. Like this now, if I get this piece of chalk and I want to toss it, then it passes on that chair. Yes? At that point, it describes a trajectory. But of course now we are looking at what we want. Now that one, if this one can describe a trajectory at a particular point. You get me? Maybe if somebody has a piece of stone and they want to throw it, then that piece of stone clears a vertical somewhere, clears a pole somewhere. At that point, it has cleared a wall. It is a trajectory. Now, we have our y. This body is moving upwards. Yes? It's going to reach at this point, the so-called the maximum height. Then it comes back. So, at this point level, its total displacement will be 0. I gave an example yesterday. You remember? Yeah. I gave an example that when it goes upwards, the distance is positive because our intention is to go up. So when it is coming back, the distance is negative. So here the displacement is 0. Then now, our target is to have this body upwards. but 40 brings down itself. Therefore, as a moving down this distance, 50 meters, it is opposing our initial line. Therefore, this 50 will become a negative because we are the opposite direction. Our target was to have this body upwards. Then, from this body comes down. Therefore, this 50 will be moved, but it will appear to be in the negative sense, as in displacement. Because displacement is a vector quantity. It has both magnitude and direction. So we are particular to direction. If I move from here to here, then come back. Say, from here to here, there is 20 kilometers. If I move from here to the gate of Mary, I will have moved 20 kilometers. Coming back, I will have moved plus 20 kilometers. So distance will be 40 kilometers. But for the case of displacement, moving, I will have moved 20. Then coming back, I move negative 20. So 20 plus negative 20, I get 0 displacement. You get me? So displacement here, I'm going to substitute, right? Of course, now that I am given 100, I have the 100 and I have the y. What has propelled me to actually use the equation of the trajectory, the y-ray angle projection? I have the horizontal distance traveled. Altogether, I have the 50 meters, the vertical distance. And now I don't have the time. Yes? And we are aware that the equation of a trajectory is independent of time. Altogether. So this is negative 50 by the explanation I have given. Are we okay with the explanation? I must go back and explain. So x, now our x is 100. Then tan theta minus g times x. This is 100 squared over 2u squared. This is 2 times 10 root 2g. Are we together? Then into 1 plus the tangent squared of theta. Permit me have g and g off. This g and the g, they go for a party. When they go for a party, you also allow me, yes? You will also allow me to make a step, yes? Now what step will I make? G has gone off, so down I remain with 20. 100 squared is 20. 100 squared is 10,000. Is it? So what is 10,000 divided by 20? So we shall have this. Let me do a step. This is negative 50. Negative 50 is equivalent to 100 tan theta minus, of course, this is 10,000. Yes, that's 100 squared over 20 root what? Root 2. The g has gone. Yes, into 1 plus the tangent squared of what? Of theta. Are we okay there? Permit me, yes? Permit me multiply through 20 root 2 both sides, such that I have this and this. What do I get?
20 with 2 both sides, like to multiply that times.
I'm multiplying both sides. I'm going to get 20 times that. This is that root. This is negative 1,000 root 2. This must give me this and that. This is 2,000 root 2 times the tangent of theta minus 10,000 into 1 plus the tangent square of what? Of theta. I divide through 1,000 both sides, yes? And I get negative root 2 is equal to 1,000. When I divide by 1,000, I get 2 root 2, yes? Times the tangent of theta minus by 1,000, 10 into 1 plus the tan squared of what? Of theta. Now I open the brackets. Negative 2 is basically 2 root 2 tangent of theta, then minus 10, I'm opening the brackets, minus 10, then minus 10 times the tangent squared of what? Of theta. Now you can see this equation is a quadratic equation. So I arrange it in such a way that it becomes 1. So I'm going to bring this. Now, this is a negative, crossing the equal signs, it becomes a positive. So 10 times squared theta, 10 times squared theta, minus 2 root 2 tan theta equal minus 2 tan 2 root theta. Then this is minus 10. Let me do it this way. This is a minus, crossing the equal it becomes a positive, yes? So I say plus 10 equal minus root of what? Root of 2. And this should give me a 0. So if tan, I'm going to let tan squared theta be what? Be x. I mean, this is a quadratic equation. We could even solve without letting, okay? It is up to you. Do you know what to press to get the answers? Because now this is the other constant, eh? The other constant will be that. I think we can, since you know what to do, but of course you must show the working, eh? You must show the working, but since we know the working, I taught you how to complete squares. Get time? So you will even complete squares. Now I will come and I solve it on the card like this. Clear the card. So equation. This is quadratic degree 2. Now my A is basically 10. Yes. Yes. My B, I open the brackets and I say negative 2 root 2. Do you believe? Then my C is 10 minus root 2. 10 minus root 2. Yes. Then I get the answer. I'm getting tan theta as 0.14142. So if I get, of course, theta 1 now, shift times the tangent of that, 14141356. I'm also getting my tan theta as 0.91579397. So considering this, yes, my theta 1 is going to be shift times the tangent of 0.141421356. My theta 1 is getting me 8.49. Shift tan 0.91579397. Shift tan 0.91579397. I'm getting theta 2 as 42.48. So they had said these angles are what?